right, ladies and gentlemen, we are starting Unit 4 today with scientific notation. Scientific notation is a way to write a really big or a really small number. A couple of vocab words that we're going to need to know. First of all, power of 10. Make sure you get this in your notes. The base 10 taken to a power that is an integer. Okay, just thinking through 10 to the 4th power would be 10 times 10 times 10 times 10, which would be 10,000. 10 to the 3rd power would be 10 times 10 times 10, would be 1,000. 10 to the 2nd power is 100. Notice each time here I'm just losing a 0. 10 to the 1st power is 10. 10 to the 0 power, remember anything to the 0 power is 1. 10 to the negative 1, remember that's the reciprocal of 10, which would be 1 over 10, which would be the same as 0.1, 1 divided by 10. 10 to the negative 2nd would be 1 over 100, or 0.01. 10 to the negative 3rd would be 1 1,000, or 0.001. 10 to the negative 4th would be 1 10,000, or okay. Scientific notation is a number C times n to the 10 to the nth, where C is between 1 and 10 and n is an integer. Okay, some examples might be like 4 times 10 to the 5th. Okay, this would be the C times the base and to the, this has to be an integer. Okay. Another example might be 9.9 times 10 to the negative 8th. Okay, scientific notation is used to write very big or very small numbers. Standard form is the way that we write a number normally using digits and place value. So like 1,000, 1,999. Okay, this is how we normally write numbers. Okay, so today we're going to be looking at taking numbers in scientific notation and changing them into standard form and the other way around. So starting with 5.2 times 10 to the 4th, what this is telling me is that I'm going to take 5.2 times 10 to the 4th, which means I'm going to take the decimal and I'm going to move it this many times. 4, because if you remember from before, 10 to the 4th power is 10,000. So I'm just taking my number 5.2 and taking it times 10,000. Another way to do that, an easy way to do that, is just to move the decimal however many times this is. So 1, 2, 3, 4. Fill those spots in with 0 and we get 52,000. Try in letter B. 6.714 times 10 to the 6th. Write your number. This is the number of times you move your decimal. 1, 2, 3, 4, 5, 6. Fill those empty spots in with zeros. And we get 6,714,000. If we continue on, 3 times 10 to the 2nd, so I just have 3. My decimal place is just at the end. Times 10 to the 2nd, so I'm going to move the decimal point 2 times. So I get 300. When you're writing your final answer, make sure it doesn't have the waves in it anymore. So this would be your final answer. Okay, 3.02 times 10 to the 9th. 1, 2, 3, 4, 5, 6, 7, 8, 9. Fill that in. 2, 3, 4, 5, 6, 7 zeros, and 7 zeros at the end there. Okay? You'll notice the patterns that you recognize. When I'm taking it to a positive exponent, my numbers are getting very, very large. So when we're multiplying by a big number, our number is going to get large. Okay? On the next page here, your next set of examples, we have a negative exponent. Remember, that changes it into a fraction, which is going to make it a really small number. Okay? So now I'm going to write 9.16, and instead of making this a bigger number, this negative 5 tells me that I'm going to go to the left 5 spots. So 1, 2, 3, 4, 5. Fill those in with zeros. And there's my answer. Again, moving to the left because it's negative, 4 spots. 1, 2, 3, 4. So I'm going to have 0.0001. .005. So again, notice I'm writing the number every time, and then I'll show where I'm moving the decimal. So 1, 2. Fill those waves in with zeros. There you have it. The last one. Moving again to the left, 7. 1, 2, 3, 4, 5, 6, 7. So where my decimal point goes. So it's .000000079. So this time, a negative exponent makes very small numbers. Okay? We can also go the other way. From scientific notation, or from standard form to scientific notation. Okay? Now remember, our C, or that number that we're multiplying times the power of 10, has to be between 1 and 10. So we want to move, our decimal point is currently there. We want to move our decimal point until it's 6 point something. So we only want one number in front of the decimal point. So we're going to move our decimal 1, 2, 3 spots. So my new number is 6.072. I moved my decimal 3 spots. So this is going to be times 10 to the third power. Okay? Let's look at another one. 10,004. I want one number in front of the decimal. So I'm going to move the decimal from here, 1, 2, 3, 4 spots. So it's 1.0004. So I move that decimal times 10 to the fourth power. Let's keep going. We only want one number in front of the decimal point, so we'll move our decimal there. So we're going 1, 2, 3, 4, 5, 6, 7, 8. We have 8, so it's going to be 3.8. All of those zeros afterwards don't make any difference, so I can leave those off. Times 10 to the 8th power. Last one. We want to move our decimal point so that there's only one number in front of the decimal. So we'll go 1, 2, so it moves 2 spots. We have 3.2 times 10 to the second power. So what do you recognize here? Well, if we have a larger number, it's greater than 1, the power or the exponent is positive. Okay, one more set of examples here. Writing very small standard numbers in scientific notation. Okay, again, I only want one number in front of the decimal point. So that would be right there. So if I move my decimal 1, 2, 3, 4 spots, my new number is 1.5 times 10. Now this is a very, very small number. To show those very, very small numbers, we use negative exponents. So this would be to the negative 4th. Okay. Again, I only want one number in front of the decimal point. So my new number is 8.2. I need to move my decimal point one spot to get there. So this will be times 10 to the, again, I want my, it's a small number, less than 1, so we're going to use a negative exponent, negative 1. Looking at letter C, I want one number in front of the decimal point, so 7. So I'm going to move this one spot. So my new number will be 7.002 times 10 to the, not the first, it's a small number, so it's going to be to the negative first power. And last one here, 0.000567. We want only one number in front of the decimal point. So this will be 5.67 times 10 to the 1, 2, 3, 4, 5, 6th power. But it's a really, really small number, so we're going to go to the negative 6th power. Okay. What patterns do we realize here? Well, if it is a smaller number, less than 1, the exponent is negative. Okay. This wraps up our introduction lesson on scientific notation. You will now have a homework assignment.